Hey everyone, in this video, let's take a look at question 100, same tree on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we are given the roots of two binary trees, P and Q, and we want to check if they are the same or not. Two trees are considered the same if they are structurally identical and the nodes have the same values. Here we can see basically everything matches, the structure and the nodes are the same values. Here we can see that the nodes are the same values, but the structure is actually different. Here we can see that the structure is the same. The nodes, the values are actually same, but they're kind of swapped here, right? So one is here, one is here, when it should be over here. So that's how we know it's false. So how might we go about doing this? Well, usually with any type of tree problem, we like to use recursion, right? So that often helps us figure out the answer. So let's maybe consider a couple of simple cases, right? Let's just say we have just two nodes, right? P and Q, and they have no children. So it's just two nodes, right? So what do we first need to check? Well, we need to check, first of all, that the actual items, like the values, is the same. So check value is same, right? Let's assume that the value is the same. Well, then what do I need to do? Well, let's say this is P and this is Q. It would really be helpful to know whether P's left child is equal to Q's left child, right? So check left. And how can we check this? Well, we can check this recursively, right? So a recursive function can basically be passed in the left child of P, can be passed in the left child of Q, and then we can check to see if they are equivalent. Same thing we could do with the right child and right child of Q, of P and Q. So we can check left, right, recursively, and if they are the same, then we know that, at least right now, we are the same tree. Now, what are some ways in which we might not be the same? Well, let's imagine a scenario here where, here we have the structure is the same, but what if the structure isn't the same? What if we had something like this, right? Here, P's left child would exist, Q's left child would not exist. So we have to make sure that we don't run into scenarios where one of them is none and the other one isn't none. The only time we know that something is exactly the same is if both of them are none, right? If we process this entire tree and then we're on P, like the number 2 here and the number 2 here, if we check the left and the right and they're both none, then we know that this one leaf is essentially a match. Same thing with here, same thing with here. So let's kind of start off with that and then see how we can translate that into the code. So I will create my helper function. The way we like to do these questions is via helper. So I'll pass in P and Q here, and I will pass in P and I'll pass in Q. So let's consider a simple case, right? If both of them are none, if both of them are null, then I know that this is essentially the same tree. So I can do if not P and not Q, then return true. What about the case where one of them is null, in this case, and one of them isn't? For example, here, the left child is null. Here, it's 2. So we can do something like if P and not Q, then this is false. Similarly, if Q and not P, this is false. What are other ways it can be false? Well, if the value isn't the same, right? Here, let's suppose it was a 2 and here it was a 3. So until this point, we know that we have a node of P and Q. So we can check if P dot val does not equal Q dot val. Then what? Well, then we know that it's also false. Now, we know that we have the same value. We know that we both exist. So now what I need to do is I need to check the children. So I can do return self.helper. Well, what do I need to do here? Well, I need to pass in P's left child and Q's left child. And I need to pass in P's right child and Q's right child. And that's pretty much all there is to this question. Let's take a look and run the example test cases. We can see that it passed, and let's go ahead and submit. And we can see that it passes. So perfect. So just to summarize, the only time we know that it is true is that if we arrive at a null case over here. If both of them are null, then we know that it has to be true. Otherwise, we have our conditions here. For example, one is null, the other one isn't. Maybe the value isn't the same. But if everything here is the same, then we can look on the left-hand side, we can look on the right-hand side, and if we eventually arrive at a case where both of them are null, then we have arrived at our answer, which is true in this case. So that's basically this question. It's a very quick and easy question to do. The time and space is basically time would be 0, O of n, because we're just going through the tree. Actually, both of the trees really. And kind of space, you can consider it constant, but you have stack space. So, just talk about that with your interview. Yeah, thank you for watching.